Welcome, everyone. Today, we're going to tackle a topic that, let's be honest, often trips students up in NEET physics: significant figures. It might seem like a tiny detail, but trust me, getting this right is absolutely key to nailing any question that involves measurements. All right, let's jump right in with a little puzzle. Mathematically, sure, 2.0 kilometers is the same as 2,000 meters. But in the world of physics, these two numbers tell two completely different stories about how that measurement was made. And by the end of this, you are going to know exactly why.
So here's our game plan. We'll start with the basic ideas, get the rules for counting and calculating down, and then we'll dive into some real NEET-style problems to put it all into action.
Okay, let's build this from the ground up. Significant figures are really all about understanding the quality of a measurement. It's about what the numbers are truly telling us beyond just their value. So what on earth are they? Well, significant figures, or sig figs as you'll hear, are basically all the digits in a measurement we're sure about, plus one last digit that's a bit of an estimate. That's our uncertain digit. It's our best guess. Really, they're the most honest way to write down a measurement. And here is the single most important takeaway. More sig figs means a more precise measurement. It tells you that a better, more sensitive tool was used. You see, a measurement of 2.00 meters implies the measuring tool was accurate down to the centimeter, whereas just 2 meters could have been, paced out by foot. They communicate totally different levels of confidence. Now, let's clear up two words people often mix up: precision and accuracy. Precision is all about consistency. Imagine throwing darts and they all land in a tight little cluster. That's precision. Accuracy, on the other hand, is about being correct, how close you are to the bullseye. Significant figures are a direct measure of a measurement's precision. Of course, in science, the dream is to be both. Okay, so we know why they're important. Now for the practical part, the skill you'll actually need on your exam. Let's go over the rules for how to count them. This table right here is your new best friend. It's got everything. Let's run through it. Non-zero digits? Easy. They always count. Zeros are the tricky ones. If a zero is sandwiched between non-zeros, it counts. Zeros at the very beginning of a number are just placeholders, so they never count. And here's the big one. Zeros at the end of a number only count if there is a decimal point somewhere in that number. Okay, time for a quick pop quiz. Take a look at this number, 0.06900. Using our cheat sheet, how many significant figures are we looking at here? Let's break it down. The first two zeros are leading zeros, so nope, they don't count. The 6 and the 9 are non-zero, so that's 2 for sure. Now what about those last two zeros? They're trailing zeros, and since there's a decimal point in the number, they absolutely count. That gives us a grand total of 4 significant figures. See? Not so bad. Just a couple of quick special cases to tuck away. When you see a number in scientific notation, you only look at the digits in the main part. You can completely ignore the power of 10. And if you have a number from a formula, like the 2 in 2 pi r, or if you're just counting objects, we say those numbers have infinite significant figures. They're perfect, they're exact, so they won't limit your calculations. Great, so you can count them. But in your NEET problems, you're going to be doing math. And it turns out the rules for handling sig figs in your answers are different depending on what kind of math you're doing. When you're adding or subtracting, it is all about the decimal places. That's the only thing you need to look at. Just do the math like you normally would, then look at the numbers you started with. Find the one with the fewest digits after the decimal point. Your final answer has to be rounded to match that. But the moment you switch to multiplication or division, you have to completely change your thinking. Forget about decimal places. Now what matters is the number with the fewest total significant figures. Your final answer gets rounded to have that many sig figs. It's a totally different game. Okay, let's lock this in, because this is probably the most common mistake students make. Addition and subtraction, think decimal places. Multiplication and division, think total sig figs. Seriously, keeping these two rules straight is a massive advantage on the exam. All right, enough theory. It's time to put this into practice with a couple of problems that are set up just like the ones you'll see on the NEET exam. This is where it all comes together. Here's a classic addition problem. We've got 3 numbers to add up. Step 1 is easy. Just punch it into the calculator. The real skill is knowing how to report that final answer correctly. So which rule are we using here? Okay, let's walk through it. The raw sum is 663.821. Now we apply the rule for addition. We look at the decimal places of our original numbers. We've got 2 decimal places, 1 decimal place, and 3 decimal places. The smallest is 1. That means our final answer has to be rounded to just 1 decimal place, giving us 663.8. Now let's try a division problem. We're calculating density, which is mass divided by volume. Again, the first step is to get the number. But what's the rule for rounding our answer this time? Let's solve it. Your calculator gives you 1.6948. Now for the rule. Since this is division, we look at the total number of sig figs. The mass, 4.237, has 4, but the volume, 2.5, only has 2. Our answer is limited by that less precise volume measurement. So we have to round our final answer to just 2 significant figures, which makes 1.7 the correct choice. That was excellent. To wrap things up, let's put together a quick mental checklist you can run through during your exam. This will help you avoid those silly mistakes and lock in those precious marks. Okay, here are the biggest traps to look out for. First, and I'll say it one more time, do not mix up the rules for adding and multiplying. Always ask yourself what operation you're doing. Second, always check for a decimal point when you see zeros at the end of a number. And finally, that tricky rounding rule. If the number you're dropping is exactly 5, you round so that the last digit is an even number. So 2.45 rounds down to 2.4, but 2.35 rounds up to 2.4. Watch out for that one. If you only remember one thing from today, please let it be this. This is the guiding principle behind everything we've talked about. Your answer can only be as good as your weakest link, your least precise measurement. It all comes down to being honest about your data. And so we come full circle, back to our initial puzzle. Why isn't 2.0 kilometers the same as 2,000 meters in physics? Well, now you know. 2.0 kilometers has 2 significant figures. That 0 after the decimal isn't just for decoration. It tells us the measurement is precise to the 10th of a kilometer. But 2,000 meters, with no decimal point, that has only 1 significant figure. It's a much rougher guess. They tell different stories about precision, and understanding that story is what mastering measurements is all about.